Here I am at the Mohanpura Reservoir and Pumping Station in Madhya Pradesh, part of the massive Mohanpura Kundaliya piped irrigation project, designed to transform agriculture across 290,000 hectares, reaching 1,100 plus villages and over 5 lakh farmers. Water is drawn from the Kundaliya and Mohanpura dams. This is the Mohanpura dam here, together storing over 1,125 million cubic meter. It flows through an intake sump, then to high capacity VFD powered pump stations, pressurizing the power for long distance travel through 26,000 kilometers of underground pipelines. This is a piped irrigation project. A multi-layered network ensures smart delivery from delivery chambers to 300 hectares zone down to 20 hectare units managed by outlet management system with several IoTs, valves and solar powered controllers. Each farm outlet serves 1 to 2.5 hectares. It receives precise volumetric supply 0.34 LPS per hectare at 20-meter head. So basically they do the back calculation, and depending on the highest field farmland, they choose the height of the tank from where by through gravity the irrigation pressure is created for the irrigation based on cost, crop specific needs, minimizing wastage and then therefore maximizing impact. The backbone is a web-based SCADA system connected via LoRa network, and 1,50,000 plus field sensors are enabled that gives real-time monitoring, automation, and 6-hour demand-based scheduling. This is the SCADA system. This is we are in the command center right now. This is the SCADA system. The SCADA is divided in two parts: the pump house SCADA and the field SCADA. This is the sump area where we are sitting here, the kind of like the pump house area, and this is the pump house SCADA we are seeing right now. It has transmitters in place that is showing the sump level, pressure gauge is in place, pressure switch is there, flow meters, color coding for the sump is also done. The rising pipe you can see in the picture, the rising pipe is taken to the water tank. The water tank was there in the video before. It helps in creating the pressure for the low lying area. So the pressure, the water goes in pressure. The two level transmitter is installed in the tank. There are two transmitter level transmitters installed on the tank because it's a critical point. Wherever there is a critical point, there are extra equipment fitted. Now we can drill down to individual details. We can see all the details of each pump with different parameters, electrical parameters for monitoring, how much power is flowing to each part, reactive power, active power, power factor, etc. What's the demand of energy based on all these things? Backend logic is set. Any parameter, if it's violated, there will be an alarm or alert generated. Now this is the pump vibration status. You can see the driving, non-driving, vibration, temperature, all the critical parameters are being monitored. Every parameter has a set limit. If any limit is again violated, then there will be an alarm. And now there are two types of set alarms or set limits. Basically, when it crosses the first threshold, an alarm is generated. If it crosses the upper limit, it is auto cut or a shutdown of the whole system is what happens in place. After this is the booster pump house. It is also called as the intermediate pump house. There are two booster pump houses in Mohanpura project. They help in boosting the pressure of the flow. This is basically the booster pump house. Now we come to the field SCADA. This is the field SCADA where data comes from the field basically. First one was the pump house automation. For the pump house automation, this is for the field automation. Here you get real-time data from 50,600 hectares. Real-time command area monitoring. This is the pipeline network of the command area. Green one is the main distributory and the yellow ones are the sub-distributory. You can zoom in and see all the control points. Red points are the sensors basically. So you can zoom in and see what is happening on the field in real time. So here you can zoom in and see all the things that is there on the ground. The project is divided into 4 parts: A, B, C, and D. Means the project or the area, command area. Whichever area you want to see, you can select from the drop down. For example, if you want to choose C, then in C, which distributary you want to check. Basically, it's approximately 300 hectares for each distributary. It will give you the focus area view. Now there are AMS system installed there, the air management system, which helps in the pressure management. And then at every interval, there are sensors in place. At any point, if the pipeline is damaged or leaked, there will be a pressure drop and alert management system will be active, and it generates alert basically to the required to the concerned authority. Now here this is the outlet management system. In every 20 hectares there is a control box in place, and this helps to check if the system is delivering water at the same rate as per design. So it basically helps in equitable distribution of water and prevents the low-lying farms getting more water than the uplands. All the flow rate, design pressure, everything is set. Also which village this division belongs to, its longitude, its latitude, everything is mentioned. Even the valve condition is also mentioned, as in what is the percentage of the valve that is open and what percentage it is closed basically, and then if it is communicating actively or not. Even the protective box that is in place, if it is open or it is tempered, there will be alarm. As soon as the box is open, alarm will be sent. So basically it is very comprehensive, and it generates a huge amount of data. The SCADA system is divided in 2 parts: the pump house SCADA and the field SCADA.
It would be designed by the currently available best ARI system, which will prevent damage to the pipe lines caused due to air gaps generated at the time of water flow or its stoppage in different pipelines, and will identify leakages at different locations. Problem-free operation of the scheme will be ensured by using the air motion system at regular intervals, for which it is equipped with smart solution, and the scheme will be constantly monitored by the SCADA system. To prevent fluctuations in hydraulic conditions and for flow of water at static pressure, sea walls will be installed in the distribution system at different locations as per requirements, and these will help in keeping the surge under control throughout the system. Outside the pump houses, for protection of pipelines and other components while discharging water from various pumping vessels, so that the damage to pipelines will be prevented in the event of high-tension electric shutdowns. This system ensures the supply of water to the alternate outlet at predetermined intervals in accordance with cropping pattern and approved usage. This system is operated and powered by solar battery backup and controls the flow rate and volume for a specified time period and ensures the continuous working of the smart system. Hydraulic SCADA system. Different parts of the line network of distribution system will be controlled by the SCADA system. This system will get live updates on the registered mobile number. Complete information about the pumps being operated at different pump houses under the scheme will also be available. Entire system can be remote controlled and monitored through cloud computing system and wireless communication system. An immediate decision may be taken with the help of this system on theft of water, leakages in pipe, and to rectify any malfunction occurring in the whole system.